Alright, so let's make flags or booleans. It's the best way to do this. Yeah, so we'll just do that. Attach to the process, hit open, keep the code list. So let's go to memory view. We are just at some location in memory of this process. I don't know where, but so we've been using the memory viewer and going around and messing with the moves and stuff like that. But at no point have we, or at least that I can recall, have we really sat down and said, what the hell is all this? We talked about opcodes. We know that move moves a value, and that we can mess with sort of the parameters or the parameters of the instruction in some predictable way, as evidenced in our scripts. So what we've been doing, there's some instruction here that we haven't really talked about. It's compare, but we'll get to that. And then we're just basically inserting this right here, and we're moving some hex value into ECX, whatever that is. It's a hardware register. And then we're moving ECX with our new value into EAX plus 34, which is some memory location with some offset. So let's talk about this. And this is a hard topic, is what I would say. It is not immediately obvious. So as we've been going through the memory viewer here, we know kind of what move does. You can sub, and Cheat Engine is even telling you down here, you click on moves, what is it doing? It's copying memory. That's basically, it gives you kind of a nutshell or a phrase that describes what this instruction is doing. What is this one doing? It is subtracting. This is copying memory, copy memory, LEA, load effective address. That's a little less clear. Move data from string to string. Let's go to push. Push word or double word onto the stack. FI add. And then you have jump, jump short, and ret. Near return to calling procedure and pop 2 bytes from the stack. High level procedure exit. And we'll highlight a couple more. Multiply by 2 once. Logical exclusive OR. That's a good one. A jump short if equal, which is conditional jumps, which we are moving towards. Jump short if less or equal, that's another conditional jump. CMP is compared to operands, and DEC is just decrement by 1. Move SX, that'll be the last one. Move with sign extension. So you can see that some of these are easier to understand, such as just a move statement, which is copy memory. That sort of, at this point, with everything we've talked about, copying memory, I mean, that should be relatively obvious, and we're not going to spend a whole lot of time talking about the move statement, if any. We'll certainly acknowledge that it exists. But basically, what we're going to get into is the x86 instruction set. And we can do that by going to Wikipedia and saying x86 instruction set. I'm pretty sure we've been here before. Let's go with instruction. We'll go with assembly language. In some previous video, I remember going here. Yeah, that's right. It was like assembly review or something like that. Let's see here. We've already read a little bit of this. x86 assembly languages are used to produce object code. It's not important about that, so we'll just skip it. Are used to produce code for the x86 class of processors, which includes Intel's Core series and the Phenom AMDs. Like all assembly languages, it uses short mnemonics to represent the fundamental instructions, or machine code if you prefer, that the CPU and a computer can understand and follow. Compilers sometimes produce assembly, and we're not going to worry about that. Regarded as a programming language, assembly coding is machine-specific and low-level. Assembly languages are more typically used for detailed and/or time-critical applications, or incredibly low-level debugging and cheating like we are doing now. So we can go to the instruction listings, which we will do in just 1 second. Let's maybe skip around here a little bit. x86 processors have a collection of registers available to be used as stores for binary data. That's what the EDX, ESI, EDI, EBP, stuff like that, those are all registers that are just bolted right onto the hardware of the processor. So they are basically hardware variables, as we talked about. Collectively, the data and address registers are called the general registers. Each register has a special purpose in addition to what they can all do. And here's a list of them, or at least some of them. The general registers, there are additionally some other stuff, some extensions, segmenting, execution modes, ring zero, stuff like that. Instruction types. So you can see that this is pretty, I mean, this is a huge article. And everything in this article is specific to the x86 assembly language. If you go to the Motorola, some other assembly language for some other platform, you will probably get another huge article like this, and it may or may not have a whole lot of correlation. But for our purposes in Cheat Engine, my understanding here a little bit is basically that it uses some pseudo version of the x86 language. So let's go to the forum here real quick. There's a Cheat Engine wiki which is worth highlighting here. There's not a whole lot of stuff on it, but it exists. Let's go to Cheat Engine tutorials, and let's say auto assembler tutorials is what we. A very in-depth tutorial on auto assembler. Let's click that. No, is there a sticky? No. All right, so let's do that. Let's see if this maybe has something to say about x86. So we'll just search for x86. It does not. That's unfortunate. Let's just do this. All right, so maybe that's not the way to go. We'll give this one more shot. We'll go to Cheat Engine, x86. x86 ISS stands for Instruction Set Simulator. This might sound a little weird, but do you? Why is my stack view? Where to learn the basics of x86? All right, so you can see that there's a question here about x86 relative to Cheat Engine, and there are some answers. And so my assumption, here we go. Mainly the basic terms you should know before starting to crack. This is x86 assembly. x86 assembly does not use 32 or 64-bit registers, only below 32. That's not right. I've never actually read this thread before, but let's read what this guy has to say. Registers are variables which are stored in your processor. That's pretty much what we were saying. The processor uses these variables for basic mathematical and logical operations. That is true. We were just saying pretty much that. The mostly used registers, or another way to say this would be the general purpose registers. That would sort of map back to our Wikipedia article. EAX, EBX, ECX, EDX. Sometimes you may also see registers like EDI, ESI, ESP, and EBP. You certainly will see those. You have flags. We'll talk about that. The term code, when you are analyzing a piece of code, you must understand that the processor is actually quite simple. It simply follows the basic instructions line by line, or more specifically, it literally is just reading in binary patterns or data, whatever you want to say. All right, that's enough of that. So let's go to up here to the x86 instruction set. Where was that? There it is. Or instruction listings. It's a whole lot of instructions. But basically, what you're seeing up here is let's go with move, because that's sort of the simplest one. So let's just search for move. There you go. What is move? It copies data from one location to another, and then it's got some other stuff over here. That's nice. So what we saw LEA right here. What is LEA? It's load effective address right here. Load effective address. So let's click on that. You get addressing modes and basically why you need this assembly instruction, which we're not super concerned about right now. But basically what I'm trying to prove here is that there's a mapping between what you're reading in here and as it exists in x86 assembly. And so if you want to know how to do something, then what you're going to do is probably go to Google and say instruction set reference. Or at least this is what I do. You can also, it's worth noting that you can just hit F1, go here, and then go to miscellaneous, or I'm sorry, tutorials, and you can read the ASM and the hexing theory and basic assembler and stuff like that. And in practice, what I actually wind up doing is I read this article or read the help file, and then I will sort of cross-reference it with what I can find in something like this. So you can see I've clicked on some of these links. Um, so in practice, that's how I deal with it. How long have I been blathering on? 10 minutes. Um, so again, that just to sort of, if I could more generalize it here, what I am trying to say is that the stuff that you're reading here, the instructions, you're going to see instructions that you don't understand, and when you don't understand them, you can click on it, and you want to know what they do, you can just click on it, and you can read sort of the blurb that Cheat Engine has. You can hit F1, and you can search for it in the help file, and you can go out on Google or Wikipedia or something like that, and you can search for it as well. And what you will generally find is that real x86s, or what you are writing in our scripts right here, these are called cheat engine assembler scripts, but they are not real assembly. I mean, they are in the sense that they have some, and that you have to follow the same sort of rules as assembly and things like that. But there is some under the hood stuff that goes on via cheat engine. I'm not super clear on it, but let's look at what a real assembly program would look like. So let's just go down here and say, let's say hello world program for Windows in MASM. We'll use the NASA. Well, yeah, we'll just go there. So here is an actual assembly program. You have some a data section and a stack section and a code section, and then you have some other stuff down here. We don't have to worry about what a stack section or a data section or anything like that is, because cheat engine, because we're not writing in true bottom line, or like, in real assembly is what I would say. And I'm pretty sure that the cheat engine help file will back me up on that. So let's see if we can get down there. About, we get about here. I'm not sure if it's in the FAQ or not. The main interface, scanning, stuff like that, custom types, no. So maybe it's this. Autoassemble allows you to write assembler code at different locations. It can be found in the memory view. We know about that. There are 3 special commands that you can give it: alloc, label, and full access. For by special, I think sort of the denotation there is that alloc doesn't exist in actual assembly, and we can just basically go to Google. I may be wrong, because again, I don't write assembly code on my own time. So let's just say assembly language alloc. Let's see what we get. Heap allocation and stuff like that can be performed in a couple ways. They can make system calls, assembly. Let's go to Stack Overflow. Let's read about allocating memory in assembly language. I'm trying to learn assembly and I need clarification on something. Please correct me if I am wrong on any of this, since I don't know much. All the tutorials I watch have variables of assembly language assigned to a memory address like 0x0. I understand that you must manually assign memory addresses in assembly, but how do you know what address to use? Obviously, it makes sense to start at the lowest memory address possible, but what if the variable you are assigning, is larger than the memory available at x, or 0x0? I'm not going to bother reading the rest of that, so let's read what this guy has to say. The answer to the second part of your question is virtual memory. You start at the hardware layer with physical memory. That's the stuff you can actually poke with your finger. This is what the OS sees. The OS lets you run processes on virtual memory. We talked a little bit about the distinction here in a way previous video. Um, so anyway, you can read all the details and whatnot, but if it was as simple as just saying alloc in an assembly language, then that is what this dude would have said. He would have said, you just use alloc. So alloc is some facility that is provided by Cheat Engine that does not exist in real assembly, and it's it should be that way, because you should not have to write real assembly to do this kind of stuff. But it is worth noting, and I've certainly talked about it at length now, that we are writing assembly code, but it is pseudo assembly, and we can use all sorts of real assembly instructions and stuff like that, like MOV, LEA, rep, and do whatever the hell we want. But that the cheat engine is abstracting away some of the true pain in the ass parts of doing real assembly. So I want to make that distinction going forward. I'm not probably never going to make this distinction again, or at least I may like tertiarily refer to it, or tangentially is probably an actual word, but I may tangentially refer to it and say, well, because it's not real assembly, then we don't have to worry about that. Let's look at there's a couple different assembly languages. Let's go to NASM. We have section data, section for initialized data, some string, something, strlen, some other stuff. Another section, global start, still no alloc, But again, you can see that they are using things like push, call, add, and ret, all of which exists in the memory viewer, and we can use them in our scripts. You can call, you can pop, you can jump, you can do all that stuff. So let's jump down the rabbit hole a little bit more. Here's a Motorola language. Can we make that any bigger? I'm not sure how that's showing up, but oh boy, that's ugly. So that's sort of this is basically sort of real assembly is what I would say. And I don't mean that this is not some deficiency of cheat engine. It's a good thing that we don't have to sit down and worry about the code section and the data section and text section and the symbols and crap like that. So let's just search this for allocate, see what we get. Nothing. So we'll just take off the E there. Assembly language is still taught. A few programmers today regularly work with assembly as a tool. The underlying concepts remain very important. Such fundamental topics as binary math, memory allocation, compiler design would be hard to study in detail without a grasp of how a computer operates at the hardware level. Let's see if we can find another word. It's not really in there. So again, if you could just allocate memory in assembly language, then that would be great. But unfortunately, you can't. And Cheat Engine abstracts away not only just the memory allocation part, but a lot of the true idiosyncrasies of working in assembly. And again, that's not a fault of Cheat Engine. That is a feature of Cheat Engine. You shouldn't have to do that or that or whatever, and you don't, and that's a good thing. All right. So the reason that I'm talking about this, and the reason that I just talked about it, is because even though this is not super real assembly or literal assembly, you still have most of the functionality of assembly, including all the assembly instructions or the opcodes, whatever you want to say, that you can use in a true assembly language, such as move, such as load effective address, such as sub, such as push and pop and call and return and leave, and all the other great weird things and the conditional jumps and compares and stuff that you can do. Um, Obviously, all those features exist, and we're seeing some of them down here. So you can use an x86 reference manual, such as this one. I mean, now we're pretty much have the same page open, but you can use a sort of a reference like this to see what the instructions that you can use are. And there's not. However, you will, when you dive into instruction references and things like this, you will see um, articles and notes and comments and whatnot that will make reference to parts of assembly that do not exist in the context of cheat engine auto assembler scripts, and you just have to sort of weed that crap out. For example, they'll be, and you just have to do it. So going forward, the reason why I want to acknowledge that it is assembly, but it's not, is because when you start looking around for instructions and messing around and whatnot, there are just things that you will read about that do not exist in the context of auto assembler scripts, and that is no accident. It is that way, and it should be that way. So let's open up new Wikipedia here. So is there anything else that I could cram into this video? Something maybe of more substance than me just talking? No. So this is just one of those videos where we had to stop and make this distinction, because we're going to start doing compares and conditional jumps and things like that. And we're going to have to talk about registers, and basically we're going to have to learn assembly. And in order to do that, we're going to have to use some reference manuals and instructions and stuff like that, or at least I do. And when we start doing that, we're going to read about things that do not exist in cheat engine assembly. And so that's why we're making this distinction now, and we will move forward in a more tangible way in the next video.